Alright, so I promise you more practice. Practice ye shall have. In this video, though, I do want to show you, there's so many cool demos in this unit that it's kind of hard to put them in one video. And so I want to show you this one. This is just 2 mason jars. You ask your grandmother what a mason jar is and she'll tell you. So a mason jar filled with an oil. Hanging in the oil is a piece of rubber that floats in the oil, right? And so they're both floating upward. And I want you to make a prediction. What's going to happen is this homemade contraption thingamajig is going to be spun. So here's the axis of rotation, right? This is the point of rotation. What will happen to these balls on a string, or these pieces of rubber on a string, as they spin? Will they stay straight up? Will they move out? Will they move in? Make a prediction, and then we'll watch the little video, and then we'll see if you can come up with a good explanation. Here we go. Oh, you might want to pause. Okay, so keep in mind, for these balls to go in a circle, as they go in the circle, there needs to be something pushing on them. Here we go, we spin them, and we see, what do we see here? Very interesting. Right, we see the balls have been pushed. They originally were straight up and down, right? But something is pushing on them this way and this way to keep them going in the circle. And it is, what is creating the centripetal force in this demo? Is it the string? Well, it's not the string, right? Because the string is, if it exerts a force, the force is going to be up and down. So if you want to pause the video, I'm going to spoil the lead here. I'm going to give away the secret. But the secret is it's actually the liquid. The liquid is providing the force that's pushing on the rubber. Now, what is keeping the liquid going in a circle? Well, it's the jar. So the jar pushes on the liquid, and then the liquid in turn pushes on the rubber, which pushes the rubber inwards, right? And so ultimately, the jar and the liquid on the rubber, those are both inward forces keeping both the jar and the liquid and the rubber going in a circle. Very cool stuff. Maybe not something you would guess right away, but you can stump your brother or sister, and you can laugh and say, physics. Okay, so now that that's out of the way, let's do some nuts and bolts. Let's do a little bit of math here, and let me throw the problem up. Not throw it up, but put it on the screen. Hang on. Okay, so again, here's our equation for centripetal force. Make sure you have this on your chapter or season 7 equation sheet. Here's our problem, centripetal force problem. Take a gander, give it a read. Let's look over it. It says a pilot is flying a small plane at 56.6 meters per second in a circular path. We're going to do something like this in class with a toy plane. So not a real plane, but a toy plane. So it's very cool. With a radius of 188.5 meters, the centripetal force needed to maintain the plane's circular motion is 1.89 times 10 to the 4th newtons. What is the plane's mass? So as I write this down, I'm going to write my knowns. And right away, this problem, they've given away the solution, right? They've told us the centripetal force. So that is a good hint that we're probably going to be using this equation to solve this. But let's write down our knowns just to be safe. So we know the velocity. Now, that is the tangential velocity, so that's VT. That is 56.6 meters per second. The radius of the circle is 188.5 meters, and they tell us that the centripetal force, so force centripetal, is equal to 1.89 times 10 to the 4th newtons. If I were to ask you what is supplying or what's creating the centripetal force, and we had the situation where we had the string, and we had our little toy plane here. Right, going around in the circle. What would be supplying the centripetal force? If you said the string, you're right. The string is the only thing that is keeping the plane going in this circle. So that's the answer. Now, as far as the math of this, we want to find the plane's mass, right? So we're trying to find m. So we look at our equation sheet, and which equation has the tangential velocity, the radius, and centripetal force. You've got it. It's this equation here. So we now can put in our equation is Fc, right? Looks like that. Now, we want to find m, so I'm going to rearrange this equation for m. And get rid of that. And this is going to end up looking like m is equal to the centripetal force times the radius of the circle divided by the tangential velocity squared. Okay, it's a lot of math, but all you're doing is an F equals ma equation, right, from Newton's second law way back from in season 4. This is just in the circular realm. So now I can plug in these numbers. So I plug in the centripetal force, 1.89 times 10 to the 4th. Keep your units in there. It gets messy sometimes, so again, we don't want to lose our units, and then we'll forget what we're solving for. This is 188.5, and that's all divided by the tangential velocity squared, which is 56.6. We check to make sure that's in meters per second. It is. And now all I have to do is plug and chug and get my answer, and I get an answer for mass of... Now think about this. If the plane were heavier, instead of weighing 1,110 kilograms, let's say it weighed 2,000 kilograms, and everything else stayed the same, what would happen to the centripetal force? Would it increase or decrease? Well, if you said increase, you're correct, right? That makes sense to us. Intuitively, we know if it's a bigger plane and it's got to go the same speed, that I have to increase the force on it to keep the bigger plane going the same speed as the smaller plane, right? And so we see logic even within the math, and that's what's great about physics, is you can use this math to predict things in the real world, such as how big a plane is. That's an awesome thing. This is a fun way to weigh yourself. It's much better than stepping on a scale. Jump a jetpack on your back, tie a string to yourself, and swing around in a circle and calculate all these variables, and you will know your weight. So either that or a scale. All right, and I promise you, if you do weigh yourself this way to get your mass, you will have fun.